Hello, in this video, we will try to learn the strategy to solve the cumulative problem in organic chemistry. And to explain these strategies, I will try to pick up one problem from the ORAP assignments of chapter 10 and 11. And here is the problem here. You have one unsymmetric alkene and that alkene is reacted with sequence of reagents like SBr in presence of organic peroxide, second one with magnesium and ether, third one is with the ketone, fourth one is S3O plus. Now your job is to predict the final product. What will be the final product? And also in solving this type of problem, you will need to figure out the step by step process and step by step product in every step, and ultimately you come up with the final product. So of course in organic chemistry, in order to solve this type of problem, you need to understand what reagent does what. Okay, which reagent does what. These are the things that you need to have the clear picture, or you need to know the vocabulary of the organic chemistry. Now for example, I will show how will you solve this problem step by step. Now, let me begin with the starting material. This is unsymmetrical alkene. The first step is reaction of this alkene with SBr in presence of organic peroxide. So let's talk about the first step. Now, talking about this reaction with SBr in presence of ROOR organic peroxide, at this time you need to know that when SBr is added across the unsymmetrical alkene, it will add by Markovnikov rule. But however, in presence of organic peroxide, the addition of HBr takes place anti to the Markovnikov rule. That means what? Hydrogen will go to the carbon with less number of hydrogen, and bromine will be the carbon will go to the carbon containing larger number of hydrogen. And with that anti-Markovnikov addition of HBr, the first step product. So that is what you need to know without a doubt. These are some of the things that you need to memorize it. Now, in this case, then your result here is here hydrogen will be added to this carbon here, and bromine will be added to the carbon containing larger number of hydrogen. So this is the first step product. Now, once you have this first step, then subsequently you need to think of the second step. In second step, you are reacting with magnesium in presence of ether as the solvent. Now, you understand that in the first step, you obtain the alkyl halide, which when reacted with magnesium in presence of ether as the solvent, then this is the reaction that will result in the formation of what we call is the Grignard reagent. Grignard. So this reaction you can consider as the Grignard reaction. So whenever you see the alkyl halide and magnesium metal, you need to realize that this is the Grignard reaction. Okay. So that is when you in the second step. So this is the first step. The second step product is going to be the Grignard reagent formation. So at this time you can avoid this hydrogen. Okay, and you have here this is that carbon, and here you have Mg and Br will be attached next to it. So magnesium will be inserted between this carbon and bromine. So this carbon and bromine, magnesium is inserted. That will be your Grignard reaction. So the Grignard reagent is generated. Now, the third step is then the reaction of the Grignard reagent with ketone. And that reaction you need to know that very clearly. So here in the Grignard reagent, the carbon that is attached with the magnesium will be slightly, that carbon will be negative and magnesium will be positive. So this negatively charged carbon that will act as the strong nucleophile, which then now you are reacting that with the ketone here. That is, this ketone is like this. This is the ketone that is reacting with. So this carbon will attack on carbonyl carbon, and oxygen will go as negative. Again, this is the reaction of Grignard reagent with the ketone. Now, this is where all the students needs to be very focused on the drawing of the product. So this is the carbon that will be attached with this carbonyl carbon. So my advice is just follow the structure of the molecule. So this is here, you have carbon, and this hydrogen is as it is. O will now become O minus. So this is the carbon where this carbon will be connected. So you can connect this carbon here, and you have rest of the group which will be looking like this one. So this is what is the product here. Now O minus, all the positive part from the magnesium and bromine will go and attach with O minus. So MgBr, that is plus. This is the third step product. Now this is again as the salt. Now there is a fourth step. You saw the H3O plus, that is just for the workup. Okay, workup, and this O minus will turn into OH. So your ultimate product will be, this is carbon here, hydrogen as it is, O minus becomes OH. This is where this whole of the group will be attached there as usual. So just you copy the drawing here. That is your final product. So this is how you come up with the final product. This is how you need to execute the problem. Okay, this is how we solve the problem related to that. All right, so this is the one part. Sometimes okay, so that is how we solve the problem in organic chemistry. That is one sequence of the reaction. Now I will solve one more problem from your R app here. Suppose, see, sometimes you will have the problem related to like say identify the organic product A, B, C, D in the following sequence. This is also a problem from your assignments. So here the problem is like this. You have your alkene, and first of all it is then reacted with number 1 BH3, and you have THF, and then H2O2 and OH minus and H2O, and second step is reaction with KBr. That will result in the formation of product A, and A upon reacting with magnesium and ether, that will result in product B, and then B reacting with your aldehyde to give the product C, and then that will react with PCC, and CS2Cl2 will result in the product D. So these are the type of the sequence of reaction that we need to follow in organic chemistry quite often. So again, the problem solving strategy, you need to memorize the function of some of the reagent and what will be the outcome of those reactions. That you need to know very well. So let us try to solve this problem. First of all, alkene reacting with BS3 in presence of hydrogen peroxide, OH minus, and H2O. So you need to know by this time that this is the hydroboration oxidation reaction that result in the formation of alcohol by anti-Markovnikov rule, right? So that is the first step. So when you do this reaction, number 1, one step here is with the BH3 and THF, and second one is H2O2 and OH minus and H2O. So that will result in the formation of uh, alcohol by anti-Markovnikov rule. That means hydrogen will be added to the carbon with less number of hydrogen, and OH will be added to the other carbon. So the alcohol, and this alcohol, this is your primary alcohol. Then you are reacting with potassium bromide. So that means KBr in the second step is just the Br minus that is coming from KBr. That will do what we call the SN2 type of the reaction, that will result in the formation of Br, alkyl halide, primary alkyl halide. And this is your product number A. Now this product A then is reacting with magnesium and ether. See, alkyl halide with magnesium and ether. Of course, this will result in the formation of a Grignard reaction. This is, you need to know that whenever you have alkyl halide reacting with magnesium in presence of ether, that will give you the Grignard reagent. So the result here in this case is magnesium will be inserted in middle, Br. So that is our product number B. Now this one then is reacting with this aldehyde. Uh, this is now reacting with aldehyde with the cyclohexane. Okay. And now for this reaction, as you know that this carbon attached with the magnesium is slightly negative and magnesium is positive. So this is the one that will react on the carbon center. O will go as O minus. Now again, writing out the product is very, very critical. So here you can redraw this molecule, the cyclohexane, and of course this is carbon and hydrogen. O will go as O minus. That is where your MgBr is going to be attached. So this will be plus. And all this carbon and all other remaining group will be attached on the carbon center. So 1, 2, 3, 4 carbon. So you have 1, 2, 3, 4. 1, 2, 3, 4. So this is the group that will be attached on this carbon center. Now ultimately there is the H3O plus, that the function of this H3O plus is to work up. That means this O minus will convert into OS group. So that is where you have your COH, and this is H as it is, and you have other group as 1, 2, 3, 4. The other group is as it is. Okay. Now this is your secondary alcohol, and secondary alcohol then it is reacting with what we call PCC in presence of CS2Cl2. The alcohol, secondary alcohol, will oxidize. This is your oxidizing agent, pyridinium chlorochloride, chlorochromate as oxidizing agent in presence of dichloromethane. This will convert into secondary alcohol into your ketone. That is where it will be oxidized. This is carbon with a double bond O, and all other attachment will be as it 1, 2, 3, 4 carbon, 1, 2, 3, 4 carbon. That is the our final product. So this is how you will product number D. This is how we conclude with this finding. Okay, so this is how we discuss the we solve the problem, the cumulative problem in organic chemistry. This portion is related to reactions of alcohol and the preparation of the alcohol. Thank you.